Okay guys, this video is gonna be to help you guys use trig to solve out 3 missing measurements of this non-right triangle. First step is to draw down your altitude, technically your height, of the right triangle that's going to be used, because you got to use right triangles, or you can only use trig functions with right triangles. We're going to call this H, and we're going to call this B1. I'm going to go ahead and draw that down here in the step 1 small triangle area. So we got that length right there is that 5. We have your right angle. This is H. This is B1. Right here we're going to call theta. And that theta is the outer angle of this angle 140. And since it's a straight line, then to find theta, you just subtract from 180. And therefore theta has to be 40 degrees. So theta equals to 40 degrees. Alright, and really in the first step, all we need to do is find the formulas for the H and the B1. Your H, since H is the opposite of the theta, and 5, the measurement that we do know, is the hypotenuse of the theta. We know that that's going to be sine, and to solve this out, it would end up being 5 sine theta, which is 40. All right. Your B1 is the same, but since B1 is adjacent, then your trig function in relation to theta is going to be 5 cosine 40. And those are the 2 formulas that you're going to use to get the exact answer for H and B, because we want the exact answers in our calculations, not approximations. We want to round and use approximation at the very end. Second step, after getting our 2 formulas, is to look at the big right triangle. So as you can see, as we drop this down, we end up with a big right triangle with X being the hypotenuse. So let's go redraw that over here. We got our H, we got our B1. That's our old base of the triangle 3. And this right here is our X. We'll deal with X later. So labeling it out, this is H, this is B1, and this is our B. So this being our B. So B1 is the formula that we used earlier, or we found, and H is still the H used to draw the right triangle. Okay. Now we're going to go ahead and place phi right here in this angle. And to find the measure of phi, we're going to use opposite, which is still H, because H is opposite of the angle phi. We're going to use the big base of the triangle, which is the adjacent. But to find the big base, I'm going to call it big B. That's the B1 that we found earlier, plus the original base B. So our formula for big B ends up being, since this part is 3, we'll go ahead and put 3 plus a B1 ends up being 5 cosine 40. Now I know I wrote that backwards. Remember that B1 plus B is the same thing as B plus B1, so you could switch those. Those don't matter since it's addition. Our H formula is still 5 sine 40. And to solve out for phi, since we're dealing with opposite and hypotenuse, so you're going to use tangent. So to get the angle, you use tangent inverse. The opposite is H, so that would be 5 sine 40. And we're going to put it over the adjacent, which is B plus B1, or B1 plus B, which ends up anyways being 3 plus 5 cosine 40. Okay, now I'm going to show you how to type that into the calculator correctly. What we want to do is, since we're using formulas, be cautious on how we're typing these in. If you miss a parentheses, as stated in class, the computer will think something else. What we're going to first do is get this denominator in there, since it's the addition of two terms. So, of course, you want to make sure that you're in degree mode first, since we're dealing with degrees in this case. And you want to go ahead and get 3 plus 5 cosine 40 into the calculator, okay? Now we're going to use that and recall it in our calculator as the last answer. So at this point, now that I have the denominator, I could plug in the whole top part. So tangent inverse, it starts at parentheses, 5 sine 40. I'll close that parentheses, which really only closes the 40 part. This parentheses is still open. And I'm going to go ahead and press divide and recall the last answer. That's second, and then the negative sign at the bottom, you have that yellow ANS. Okay, you can close the parentheses if you want. And that tells me that phi, the measure of that angle, is 25. I'm going to round that to 0.2, because on this one you're going to round to the nearest tenth. So there's our first answer. Phi equals to 25.2 degrees. All right, that's the first answer. Second answer that we need to find is alpha, which is this upper angle at the top, and it's actually not this angle. Alpha is actually this angle of the smaller, it's a smaller angle, not the full angle that I mentioned earlier. So alpha is the original upper angle in this triangle. And what we need to know about this is that alpha is part of this triangle, which has a total of 180 degrees. And if we know that this is 40, we could subtract 140. Sorry, we know that the bottom angle is 140. We subtract 140. And we subtract phi, which we now know is 25.2, held in my calculator, as you can see. So to find alpha, you just need to subtract those values from 180. So I could take 180 minus 140 minus, and since that 25.199 is the exact answer for phi, I could just recall that as the last answer. And the most precise way of doing that is stated, and therefore alpha, that measure of that angle, has to be 14.8 degrees, which kind of goes off of the approximation that we did too. So you could kind of get away with it that like 99% of the time. Last part is to figure out how long this x is. This x, remember, is still part of this big right triangle. So we could use the right triangle properties, and the one that is the easiest to use without trig functions is a squared plus b squared equals c squared, where we'll call this c, and this is going to be kind of confusing because we have a whole bunch of b's here, but I'm going to call this the a side, and therefore my h is going to be my b side in a squared plus b squared equals c squared. So we're going to go ahead and write it out as x squared equals to, well, this a is actually 3 plus 5 cosine 40, and we're going to square that quantity, plus b squared, which is just the h formula, and h once again is 5 sine 40, so 5 sine 40, and that's going to be squared. All right. Now the reason why I wrote this out is because it's easier to get this in the calculator first and then start adding everything else. So what we're going to do is get the 3 plus 5 cosine 40 in the calculator first. That's the first step. Second step is to square that quantity. So if you just press squared, it says the last answer is squared. So now we got it squared. And now we could go ahead and add all of this in to the calculator. Since there is no addition inside the parentheses, you could get the calculator to do all of that with correct use of parentheses. So we're going to add, we're going to start a parentheses. You're going to type in 5 sine 40. Now remember that 40 doesn't have a parentheses to close, so we'll close that one first. That closes just the 40. But remember, we want to square that whole quantity, so we'll close it twice. All right, so this first one is to close the 40. The second one is to close the whole quantity, of which when we press squared, we want to square that whole thing. So now when we add that together, that's what x squared equals to. And To get x squared as just x, we square root that. And those cancel those out. But if you remember, the square root of x is the same thing as x to the 1/2 power or x to the 0.5 power. That's the easiest way for me to type that into the calculator, x to the 1.5 power. So I'll take this last answer, press the exponent button, which automatically takes the last answer, and we're going to put it to an exponent, and we're going to do it to a 0.5, which is the same thing as 1/2, which is the same thing as square root. And x ends up being 7.5. And that's the last part of the answer. And these are your answers for the missing measurements of that original triangle.